Today we're going to take a look at ellipse in general form. What we're going to want to do is put into standard form so that we can identify all of its characteristics so we can then graph. So let's look at our example. Right now it's in general form where everything is onto one side. What we're going to need to put in standard form is we're going to have to put the constant onto the opposite side as well as group our x's and y's together so we can complete some squares. So first off, we're going to move the -3 over by adding 3 on both sides. And then we're going to group our x's. Factor out the 4 that goes along with it. So that gives us 4 times the quantity of x squared plus 6x plus, I'm going to leave a little space here. Plus, there's nothing to factor out on the y squared. So y squared minus 10y plus a little space here. Okay? So what do we need to do to complete the square? We need to take half of 6 and square it. That would make 9. Now, what we're going to want to do is make sure that whatever we add on this left-hand side, we add on the right-hand side. We didn't just add 9, we added 4 times 9. So I'm going to put 4 times 9 on this side. Then, on this side, we take half of -10 and square it, and we get 25. Since there's a 1 out in front, we're really just adding 25. So we can then go ahead and factor these trinomials. So we have 4 times the quantity of x plus 3, quantity squared, plus y minus 5, quantity squared, equals, well, this is really just 36. And when we add 3, 36, and 25, we get 64. So one more step we need to do in order to get our equation in standard form, we need to make sure the right-hand side is 1. In order to do that, we divide both sides by 64. So that side by 64, and while we're at it, we'll divide each of these terms by 64. So we end up with the quantity of x plus 3 squared over 16 plus the quantity of y minus 5 squared over 64 equals 1. And this is our equation in standard form. There's a couple things we can tell just by looking at this. Our center is at h, comma k. H always goes with the x. So what do we subtract in here to make this equal to 0? We have to subtract 3. So our center is at -3, comma. What do we have to plug in for y to make this equal to 0? 5. If you want to look at it another way, it's really opposite of the number that you see on the inside is our center. Okay? Well, we can come right over here and plot it. -3, 5. Kind of hard to see with this. Okay? Now, the other things we got to think about is what is our a squared and what is our b squared? A squared is always the larger of the two denominators. So when I look at this, I see 64 over here. So a squared equals 64, or a equals 8. Our b squared is always the smaller of the two numbers. So b squared equals 16, or b equals 4. Another thing this tells me is, since our larger number, or a, is underneath the y, our ellipse will be elongated vertically, like this. Why is that helpful? Because it tells us how to go then find out what our vertices are, our foci, and our covertices. So if our center is here, our vertices have to be vertical to the center. So we have to shift up and down, or move up and down to find the vertices. We're going to use our a value there. And since we're going up or down, we're going to add it and subtract it to our y value. So our vertices will be at -3, comma, 5 plus 8 and 5 minus 8. So 5 plus 8 is 13, and 5 minus 8 is -3. Our covertices will be left and right, here and here. So covertices left and right. So we take our b value and add it and subtract it to the x in this case. So -3 plus or minus 4 becomes 1, comma, 5. Always come back to the center here because this is where we're moving from. And negative 7, 5. The final thing we need to find is the foci. The foci are always along the major axis. So they're always also on the same axis of symmetry that the center as well as the vertices are on. In order to find that, we need to find C. And remember, with a ellipse, our equation that relates A, B, and C is a squared equals b squared plus c squared, or c squared equals a squared minus b squared. In this case, it makes a little bit more sense to use this one because we already know a squared and b squared. C squared equals a squared is 64 minus b squared is 16. So c squared equals 48, which means c equals 4 square roots of 3. And we're going to use that and add it and subtract it to the y's, just like we did with the vertices. So our foci is really just negative 3, comma, 5 plus or minus 4 square roots of 3. If we really want to graph these, then we'd find an accurate estimate for 4 square roots of 3, and then we can simplify down and give some decimal. But for now, this will be good, and these are our characteristics that we want to look for. So remember, we have our center already graphed. Our vertices are at negative 3, 13, and at negative 3, negative 3. Our co-vertices are at 1, 5, and at negative 7, 5. And a quick little sketch, we can then come around and do the best that we can to make a nice, smooth, almost football shape, so to speak. And here we go as our graph for this ellipse. Hopefully this helps you out with some of your problems.